So to be ready for your test, you, you need to just put the rules together that you discovered when you were playing around with the blocks and doing your investigating of patterns. And the things that you folks kind of together decided was that these problems are easiest if you figure out the change from one term to the next or one position to the next. And that's the first thing you do. Find out how much it changes. And then the second thing we did was find out what's left over, is what we'd been calling it. The way we go about doing that really is we find our first term, and let's say it's 4. And we find our change, let's say that's 3. And all we did was find 4 minus 3 equals 1. And that would be our leftover part. Might sound a little confusing, but when you see it kind of work out, so I'll make a pattern that goes like this: 5, 7, 9, 11. Pretty straightforward. And I ask you, tell me the rule. Tell me the rule that makes this work. So this is the first term, this is the second term, this is the third term, this is the fourth one. Or instead of term, maybe use the word position. But either way, I need to figure out what rule will work for this in terms of like the number equals position number times something plus something. Or sorry, plus something. Remember, first thing we do is figure out how much it changes. From 5 to 7, it changes by 2. The fact that when I look at this pattern, it changes by 2 every time, I know that that means there's one group of 2 in here. There's going to be 2 groups of 2 in here, 3 groups of 2 in here, 4 groups of 2 in here. That means that the multiplier is 2. So if there's one group of 2 in this one group of 2 right here, how much is left over? Well, one group of 2, if I got rid of that 5, would be 3. So 5, take away that one group of 2, is 3. Now I use my other terms to check if that makes sense. 2 times 2, that means 2 groups of 2. That would be 4. How much would be left over? Well, the other 3. And that would make 7. 3 groups of 2 would be 6, and another 3 would be 9. 4 groups of 2 would be 8, and another 3 would be 11. So this totally works. And that's kind of the basics of finding our rule. Now if I asked you for an nth term, instead of times 2 plus 3, you would just say 2n plus 3, where n is the position number or the term number. So hopefully that makes clear what you can do in terms of how to find the rule. The first thing you ask yourself is how much it changes. Then think about that. Think about how many groups of that multiplier are there. Now keep in mind that in actuality this is called the multiplier and this one here is called the constant. Now the multiplier is the one that is being grouped over and over again. There's one group of the multiplier in the first position, 2 groups of the multiplier in the second position. So you can find that easily by finding out just how much it changes from one term to the next. Then the constant will be, if I remove that one group of the multiplier from the first term, what would be left over? And that's why we called that the leftovers. So find the change, find the leftover, and you can put that together to find your rule. So sometimes it won't be so nice and easy. Like when I looked at 5, 7, 9, 11, the change was 2, and when I took one group of 2 away from 5, there was 3 left over, so I knew it was times 2 plus 3. What if when I take away that group, it's not a positive number anymore? Or what if this number isn't big enough to take that group away? For example, in our first question of our homework, 4, 11, 18, 25, when I look at the change here, it's 7. That means there's a group of 7 in the first term, 2 groups of 7 in the second, 3 groups of 7 in the third, 4 groups of 7 in the fourth. Now, that's great. But how can there be a group of 7 if the answer is 4? If the term value is 4, how can there be a whole group of 7 there? That's when we're looking at negative numbers. There's a whole group of 7, but then there's also a constant as well, and that constant actually has to be negative this time. So think about that. If there's one group of 7 in my first term, how many negatives must there be to bring that back down to 4? Well, 7, and then 6, 5, 4. So I know that there's actually going to be 3 negatives there. So I know my multiplier is 7, and I'm also going to have 3 negatives. Now, adding a negative, that's really the same as subtracting. So often you'll see it as times 7 minus 3 or 7n minus 3. But when you're working with something like this, please keep that in mind. If it doesn't seem like it's going to work because the constant is bigger than the first term, then you know your constant's going to be negative. Hopefully if your multiplier is bigger than your first term. Sorry, I misspoke for a second. If your multiplier is bigger than your first term, then you know your constant is likely going to be negative. So the rest of that question says, use your rule to find the 25th term. Well, 25th term equals 7 times 25 minus 3. 7 times 25, well, think about quarters. 7 quarters is $1.75 minus 3 equals 172. And that's how that should be laid out. Hopefully that would make it fairly straightforward. Same sort of thing when I'm looking at negative 5, negative 3, negative 1, 1. It's going to ask me, write a rule to describe. First thing I look for is the change. Negative 5 to negative 3, that's getting more positive. It still is negative now, but it's moving in the direction of becoming more positive by 2. So that means my multiplier is 2. There's groups of 2. There's one group of 2 here. There's 2 groups of 2 in the second one, 3 groups of 2 here. So now I have to figure out, well, what's my constant? If there's one group of positive 2 here, then there's a whole bunch of negatives as well to end up with that kind of negative 5. So how many negatives must there be if there's a positive 2 there to get all the way to negative 5? Well, it must be negative 7. Because negative 7 plus positive 2 would bring me back to negative 5. There's another really easy way to look at this if you're looking for what the constant is. Now, the multiplier is straightforward, like we've been mentioning. Negative 5 to negative 3. It's positive 2. That's the direction to move, so my multiplier is 2. That part's easy. If you have a hard time finding, well, what's the plus or minus part? I know the multiply part. I don't know the plus or minus part. All you have to do in your head is go back one more. Negative 1, negative 3, negative 5, negative 7. So you'd put a minus 7 there. If I gave you a different pattern, say 3, 8, 13, 18. You could look at this and say, oh, multiplier is 5. What's the constant? If you struggle with that, if you struggle with, oh, there's a group of 5 and each one, group of 5 here, 2 groups of 5 here, 3 groups of 5. If you struggle to picture that because maybe you don't remember how the pattern blocks worked or maybe you didn't quite get it back then, go back one. So it goes up 5 each time, so it goes down 5. That means that would be negative 2. That's another trick you might want to use. So give that a shot. But at any rate, our second question was times 2 minus 7. So that's our rule. What's the 10th term going to be? Well, 10th is going to be 10 times 2 minus 7 equals 20 minus 7 equals 13. So that's the answer to the second question. So the question asks for one more thing. Nope, I don't know what it's doing there. What's the 4,356th term? Well, 4,356 would equal 4,356 times 2 minus 7 equals, that would be 8,712 minus 7 equals 8,705. So this number just came from here. 4,356 times 2. And then you subtract the 7 and you're done. That's question 2.